So an important point in Gephi is that you have the ability to map your data to visual attributes. For instance, here we use colors related to the degree of each node. Each data node attribute or edge attribute can be found using the data laboratory. What you see until now was a part called the overview. It is a place when we do real-time analysis, real-time exploration. But you can use Gephi also to just see the data like in Excel. So if we go to the data laboratory, you will see here the table of each node. And so you have the different nodes and the different attributes. Here I have only the modularity as an attribute. And I can see the various edges with also the type of the attribute, their weight, and maybe other information. So we can map each of this information to the graph according to, well, if it's more suitable to visualize it for ranking or for visualizing groups. So well, I forgot to say at the beginning that if you click on a node, you can move it. So depending on if you want to visualize your network and move the elements by hand, if it's feel better, it's up to you. Of course, if you use a layout, you will prefer to try to analyze the distances directly. So moving elements is a little bit about cheating, but it can help. I mean, the main game here is to better read the network, and sometimes we just have to find some tricks to better visualize it. So it's not a perfect science. It's not all the distances are not measurable. I mean, it doesn't mean anything in the absolute. So it should be, you should read it by just seeing the distances locally. I mean, relatively compared to others. Do you see two elements who tend to be closer compared to the rest of the network? Do they tend to form groups, or do they tend to be at the opposite of the network from one point here to one another, for instance? So you don't have well, the coordinates doesn't mean anything. And of course, while there is no north, south, east, west, which is a real problem, because these layouts, if I run, for instance, the force atlas again, and I start to drag an element, I will see the network which is rotating. It is still the same structure, and in this sense, the algorithm is very stable on this network. So I can try to shake a bit. I will make it more slower so that you can see. Also, don't hesitate to try different things, different parameters, just to figure out how does it look. Here, for the layout, I can change the parameters in real time, and that makes some experiments very easy. For instance, well, I want more repulsion. Well, I just do it. I want less. And I see how does it change. The layout is also has a kind of center. I mean, the center of coordinates. And so there is a parameter called the gravity, which will tend to attract more the elements to the center of the space, so that elements don't go too far. So it is called the gravity. If I increase the gravity, for instance, I will start to have elements which tend to be closer. So you see that the distance is really relative, and you should read it very carefully. We are also interested in just reading and following the links. I mean, imagine that you start from this element, and okay, after that you go to this one, and maybe after that you will go to this one, and you try to follow just, okay, I want to explore what are the links. It may be useful if you have real questions on some particular elements of the data. Here it's not related to finding some particular property, or, well, it's really, okay, I want to read my data, but not in an Excel view, to see and explore the local connections. So that's sometimes very, very useful. I work with sociologists and researchers in humanities who have an interesting use case. They have a database of the correspondence between philosophers during the Enlightenment. And so they kept half of the letters philosophers like Voltaire, Franklin exchange between each other, and many other information. Where did they travel? Where did they meet? Do they have family? What was their religion? Many, many things. So they have this database, very incomplete, very messy, and they use the network visualization to go faster in the big set of documents. I mean, it is roughly 50,000 letters. They don't want to read all the letters. So they use visualization to go faster in raising some questions, some hypotheses on what's going on. So for instance, do this philosopher exchange more letters with a particular group of philosophers in Scotland because he visited Scotland some years before? That are the kind of questions that are very interesting for historian people, because they may have previous knowledge of this particular philosopher, what was his life, what he's done during it. And comparing to the data in this way helps them to check if there may be some problems, some inconsistency in the data. And if this kind of element of event happens, well, it's interesting to do research about it. So I will stop. Well, so going back to mapping elements in the network. So here we have seen that, okay, we can map the degree of the node to the colors or to the size. We may use also another way to color the elements based, for instance, if they belong to a specific group. So on this data set, I've previously computed community detection algorithm. Who knows what is a community detection algorithm here? Clustering. So it is an algorithm that will try to group different elements based on specific properties. So for the network properties, it will be relied to the topological structure. In Gephi, we implement one algorithm specifically, which is called the Louvain modularity algorithm. And when computed, it will produce this visual. So here it is available as a modularity class. So for each element, we have the specific group computed by the layout. And for each group has a different color. So I apply it. And this is how the algorithm performs. So for instance, in this area, the algorithm identifies that these nodes belong to the same group. That's interesting to be able to compute it automatically. Or this other group. This one. Or something more questionable, like this one, or this one. And so it is a good way to color the network and quickly see what are the groups based on the topology. So only the structure of the network. And in Gephi, well, if you want to compute some statistics on the network, we propose some common algorithm. So on the right, you have the statistics panel, and you have various statistics about the whole network, about the nodes, about the edges. So, for instance, if you want to run a page rank, you can here select, click on run. You can compute, you can set different parameters. Well, I won't change anything here. Click OK. Well, have some basic results, but I don't care. What I want to do is just first, in the data laboratory, I will see that for each node, I have a new column and the result of the ranking. And I will use directly this result in the visualization. Okay, the algorithm provides me a ranking of the elements. I will check if it makes sense. So here in ranking, I select page rank to size the elements. Now I click on apply. And so for the algorithm, okay, I can see that Valjean, Myriel, and Gavroche are the top. But it's more interesting to see where they are in the network, because there may be biases about it, or maybe the algorithm doesn't really answer our question about the ranking. So for instance, do we want the ranking to be global and see, okay, it is obvious that this node is the most connected, the most important one, or maybe I should better rank these different nodes in subgroups. Well, it depends. But at least when you have the results, you can see how it is relied on the network topology and to understand what is the context of each of the nodes. It is one of the main reasons about not only visualizing the network this way. It is because, okay, even if I can see the edges here, I want to have a better sense of what's going on around a specific element, around a specific edge, and so I want more information on the context, locally or globally. And so this is why visualization may be very useful. I mean, I don't expect anything on this data. At least if you have read this novel, you can rely on some particular part of the script, but that's all. And maybe visualization will help you to find some ideas. Or I will give you an example about a very recent research. It is about analyzing the script of various films. I mean, each writer, scenario writer, have his own style and will organize the story differently. And I know there is a guy in Dublin who is working on it. He wants to identify automatically what are the different styles of stories based on the network topology when two characters appear in the same scene of the film. That's interesting, quite difficult. So he wants to compute some statistics and try to identify if there are some groups that can be identified by statistics, but he also provides a very good website where you can check, visualize the network of each of the films. So for instance, there is Pulp Fiction, or well, many things. It is called, we'll give you, if I remember, it is moviegalaxy.com. Well, going back to Gephi. So we have seen how we can run a statistic. So for instance, a page rank. We could run another one. So for instance, graph density. And we have the result. We could run also more complex algorithms. So for instance, to identify other centrality values, there is different ways to compute centrality. So there is obviously the degree. Well, you know now the page rank, but historically in sociological science, you have other centrality metrics like betweenness, which is the measure when the nodes appear on shortest path on every path on the network, or closeness centrality, which is the average distance from a given node to all other nodes in the network, and others. So depending on the question you have, you will focus on different ones. So if I compute them, I can reuse the result in the visualization. So still, now they have become available. And for instance, I want to see the betweenness centrality, and I will map it to the color, not to the size. I apply it, and well, it's very consistent with the page rank. But for the size of the node, now, if I use only the degree, I will see some strong variations. So here, for instance, this node, it has a very low degree, but apparently it appeared regularly on the path on all in the network. So it may be an important node according to according to how information could spread in this kind of network, according to what we call the betweenness centrality. But it's not important according to the number of direct connections. If you want to remove all the colors and size, you have the different tools here at the bottom left, when you can, for instance, center the view. Imagine that at one point you are lost and you want to see your graph. You click here. Here, I remove the colors. I reset sizes. If I right-click, I can set another default size for the nodes. And so I can also filter the network. For instance, I want only to see the top elements of the network. So I go here to filter, and I have various filters that are available. So here I will filter on the topology only. So for instance, taking the degree range, I will want only the nodes between 15 and the maximum of connections, and I click on filter. But I can change it directly. Otherwise, I want to hide the most connected elements to see what happened to the network. So here, I remove the top, and I start to see that the network, well, it's still connected. It's an interesting finding. If I remove the most important characters, okay, the network seems still connected. If you have a transportation network, that will mean that if your most important nodes are under attack and they get down, you can still transfer information. It's also interesting to see how we can better see the structure of groups if I remove the top connected elements, to see what could be the core communities. And I click on filter again to deactivate the filter. I can also filter by groups. For instance, here on attributes, I will select the results of the modality class, which is a partition of the network. And so I want to see only the group number 8 plus number 6 plus number 1. Oh, I want to hide the number 6. Okay, I see that there are connections between the two. Oh, if I go to partition, I will color the classes again. Okay, now I see much better how the two groups are connected. So for instance, well, your question, I want to see if there is a connection between this group and this group. Here it is based on the groups found by the community detection algorithm, but it could be also groups defined by your data. I mean, you know some information about these people. belong to the same company, they are from the same city, and you want to see in your data how two cities could be connected, or how two people from different companies are interconnected. Okay. Well, so it's all right for the basics here. Now we want to, well, I will change again some size. Okay. And now for me, the network is fine. I want to export an image I can use in a report or anything else for print on the web, whatever. And so here, I will better refine the visualization. So better change some aesthetics element, for instance, fonts, other ways to use colors. So I go to the preview tab. Well, little bug, I have to refresh. And here it is what you see is what you get. So you will export it directly. So you can refine it on using the parameters on the left. And so for instance, if you want to show labels, I can activate them. I want for the labels to use another font. For instance, this one, which will be smaller also, and have it. Imagine that I want also boxes around the labels. Maybe it can help me to better visualize it. I may want to hide the edges because maybe, well, there is so much edges that I don't see anything, or the position are fine for me. I just to have this this tag cloud, so I deactivate them. Okay, but I want them anyway. I can change the thickness of the edges also. By default in Gephi, the edges will be larger if the weight is larger. So it is important here to understand that it is because we assume that the weight is related to the strength of the connection. And many layout algorithms also make this kind of hypothesis. So I can change it by 0.5, for instance. I can change the color of the edges, for instance. So here, I want, by default, the edges, the color of the edge is the color of the source of the edge. But it could be something different, or it could be just the color I want. And well, if it's fine for me, it's okay. I can export here in an image format. So I could export in PDF, so to print directly. I could export it in PNG, quite useful. Or in SVG, if I want to modify the image, add more information, for instance, a legend, title, something like that. So I export in PDF. Here at the bottom, I wait that the process finished. Gephi is multi-threaded, so you can perform various tasks. For instance, running a layout, computing a statistics, applying different colors, everything directly. So, and here, okay, I have my PDF. So when you want to save your data, you can save it in like a Gephi session file, but unfortunately it's open source and we still have some bugs, some problems. So I will advise you to use another file format to use. So in File, I go to, not to save, but export as a graph file. And here I can export it in many formats, depending if you want to use another network software, GDF for Guess, DL for UCINet, or GraphML, which is quite a standard. And for us, we prefer to use our own baked format, which is called the GXF. So about it is an XML file format, and it is mostly made to support dynamics on networks. So it has some. It is much more supported for attributes and dynamics than GraphML, for instance. And so I can choose also to export all the information and only some information about the data. And okay, I save it. So this is this file. And if I load it now, so when I load a file in Gephi, I have this window, which is provide me an import. Here it basically says that everything is fine. I'm using a specific version of the GXF parser. Default edges are undirected, but he will try to find some errors, some inconsistencies in your data, so that you don't have some bad data that you start to visualize. And if you have troubles in your data, it will try to tell you at which line in your file there is this kind of trouble, or if there is some node missing, some information that is not doing well. That really helps. And here, okay, I have my network loaded again. I will load another network now with more data, something more, well, useful, I would say. So, for instance, researchers in sociology were interested in how people use the web to get organized when they become part of a diaspora, when they leave their country. And they get some information about the various diaspora, like the Russophone diaspora on the web, or Moroccan diaspora. And I will provide you this data very quickly so you can play with it in Gephi. And what is interesting here is that the researchers qualified each website with information about who is behind, what is the frequency of update, or what kind of communication tool the people use, comments, forums, etc. So you have also qualitative information which is verified by a human, something very hard to obtain otherwise by using automatic crawlers. So it's okay, still a small network. Here I barely see the links, so I can easily change the size of the links using this slider. And so this dataset is a Moroccan diaspora. You will play with the Russophone diaspora if you want after. And I have many information, many columns in my data. So here the resolution screen is too low, so I can't see anything. But at least I can use the information here in partition and in ranking. So for instance, I'm interested in maybe some category about each website. So some websites are held by associations, some are just blogs, some are official websites, etc. Media, business. I will apply the color. And what is interesting here is that I can directly see a correlation between the structure of the network and this property. For instance, here I see a group, a community, which is all the elements are strongly connected. I see many links between each of us and very few links to the rest of the network. And they are all blogs. So what does it mean? Bloggers tend to make links only to other bloggers and don't care about the rest of the web? Well, probably. But more interesting about institutions here. That should be at the center. I mean, they provide public information, public services. Why do people care so less about it? Maybe they are just bad, or maybe they are very badly made and the government should make a stronger effort to better develop this website. So with this kind of visualization, you can quickly have research hypothesis. And after that, you will go back to the website to see what's going on exactly, to better understand how people use it. Maybe use complementary analysis, depending on the study. So this is how the researchers use this visualization to better understand, okay, I have my sociological question, so I want to understand how people use the web. I'm not interested in by statistics or properties of this network, but it is more about how people use it. So with this kind of visualization integrated in my methodology, I am able to raise good questions very quickly. I don't have to keep in mind 150 websites to imagine, okay, maybe something happened in this data. So this is mostly used as an interface between you, the analyst, and the data or the document, the set of documents you are interested in. You can see this visualization, the exploration, as a tool to go faster, like a search engine. Also here, another interesting element of the network. Media websites are totally disconnected. well, if they had a real web strategy, they would connect to other websites. Otherwise, you see that people don't care about them, even if they are media, journalists, whatever. So this kind of map can also help these people to build a strategy. Okay, I am here in the network. Why? How should I go to the center? Or how should I get connected to the other people? Or I discover that there are also interesting websites about another topic or closely related topic. Maybe should I contact these people? Another network now. Well, I will try GitHub. I don't have everything. Too bad. So I will take a subset of United States developers active on GitHub. So this is a bigger network. 11,000 elements, 43,000 edges. Start to be interesting now. So I will select a layout. So to go faster here, I will select another layout, which is also available by default in Gephi, which is called the second version of Force Atlas. Just 2 words about it. Force Atlas is a homebrew layout. We developed it for Gephi to better improve the readability of the visualization. You will find many other layout algorithms which emphasize different kind of properties of the network. So for instance, there is a layout that will tend to get everything in a cycle. So Frosterman-Reingold. So for small networks, it's very good. And it distributes the nodes equally in the space. That can be helpful. There is this algorithm that will try to identify groups and also connections between groups. You can easily read them. You will have other algorithm which is run much faster to better identify clusters. So if I run this one, it will be a mess. Also because, well, there is a node here that is connected to many others, and it starts to be really difficult. So sometimes we have just to wait that the algorithm compute enough time to get a visual. So I can help it a bit to increase speed, for instance. Can we see? Well, start to be quite stable now. Not a good idea. Okay, we'll stop it now. This one. Okay. Okay, this is a blob. We don't see anything, almost. So, how can we use it? How can we start to dig inside this big hair? People like to say that it is a hairball. Like you know the cats when they have, or just you have spaghetti, potatoes, just something that seems apparently to be useless, but we'll see. So what kind of attributes do we have? So each node here is a developer. Each link is a link of friendship. You know, you can follow some people on GitHub. So this is this link. So you have the country of the people. You have the number of followers. You have the main language of the project. You have the number of repositories. And here, I did not remember what it is exactly. So let's see first country. Okay, here this data is mostly about United States developers and their direct connections. So unfortunately for me, I don't see any particular partition that emerge. Okay. Maybe I should try language. Much more interesting here. So even if this network is very big, start to be quite big, yes. I have now a very good hypothesis that people tend to follow the developers who develop in the same language. Seems obvious, but not that much. And what will be more interesting here will be, I want to see only, for instance, I will filter a bit based on partitions. And I want to know the connections between PHP and Perl. Okay. So don't look at these colors. There is a bug. Look at these ones. And I will increase the size of the nodes to better see. So here, I have only these connections. Well, the structure here it helps me to see that there is stronger connections in this area. So it will be interesting for me to look at these accounts and figure out more closer what is happening there. So the way I use a visualization, I take the whole, I filter on some details, and so I will only look at closer a very few number of elements in my data set. instead of looking at every account, I will start with a question: what's happening exactly in this for these accounts to be so connected? Because they have two different languages. If I want to use another layout only on this data, I would create a novel network based on this filter. And so here, yes, I have an option to export the filtered graph to a new workspace. In Gephi, you can work on different graphs in parallel. You have on the menu in workspace, you can create novel workspace who are totally independent. It is, and from the beginning, I've not closed any of my data. I can still go back to Les Misérables. Well, another Les Misérables which I've loaded, the Moroccan blogosphere, and GitHub. And so here I will create a new workspace. All right. And based on this one, I will apply a layout. Still big. I will collapse it. Okay. Not good here. Okay. So for this group, which is Perl developers tend to connect to every other Perl developers. I mean, everybody is connected to almost everybody. This is something crazy, but they rarely connect to other people, to other PHP developers. So here I can see that the connections, okay, I have these guys. I have this one. I have also some isolated elements. So there is not so much connections between the two groups of developers here. Too bad. But I've checked it very quickly. I may try another layout for larger network based on an algorithm which is not available by default in Gephi, which let me to introduce the plugins. So Gephi is not only a tool that you can take it and you use. It's a coding platform. So I mean the code is open source. So you can get it, you can modify it, you can use it for free for whatever you want. And you can also create plugins for Gephi. So you can create another layout if you want, implement a statistics, or do, well, whatever that will connect. It's in Java. So here, if you want to see the plugins that are available in Gephi, it's very easy, because you just go to Tools, Plugins. I'm not connected, but I should still be able to see, for instance, in available plugin, I have all the plugins developed by the community. And so I may find some which are interesting. And after that, well, I can select one, for instance, the scripting console, which is a Python console in Gephi. And I will click on install. I restart Gephi, and it's it. So very easily. Very good also to code something and get feedback from the community. Also for updates. So we publish novel release of Gephi regularly. We try to do it every 6 months. But we also provide hotfix by an automatic update system inside Gephi. So if you are connected, Gephi will try sometimes to check for new updates. And if they found new updates, like we fixed some bugs or we implemented novel features, you just click on update and you will get it on your Gephi. No need to wait for another release or install Gephi again for a novel version. And if you want to check it manually, you go on help, check for updates. And it will tell you if we have something to fix. So if you just install Gephi, please apply the updates. We fix many things. So here, I will use another layout. So this layout is called OpenORD. Very efficient, very fast for very large network. I mean, it can be computed in less than 2 minutes for 100,000 of nodes and edges. So it's interesting. And you see on the bottom right the evolution, the progression of the algorithm, which is very specific here. Okay, it's kind of. Can I see better? So here the distances means something totally different. I mean, this algorithm will try to identify communities and to explode the network to reveal the different subcommunities. So this is why it is more difficult to see many things, but at least we find here some interesting groups. And if I just want to hide the edges because I have too much edges, I can see which nodes tend to be closer. And it may be interesting to see the correlations between this algorithm and a community detection algorithm. Sorry? So basically, if you have 2 gigabits of RAM and a computer that has less than 5 years, you can work with small networks of hundreds of nodes. That will be fine. If I after that, well, it will depend. To have larger network, I mean more nodes, you will need more memory. And if you have more complex graphs, I mean more edges, you will need more computing power, more CPU, because most of the algorithm, you know, well, but there is, well, officially 1 million, but we'll never reach the limit. The problem is that if you have enough memory, Gephi won't crash. You'll be able to load the data and try to start some algorithm, statistic or layouts. Yes. So I know some big companies who are using it with 500,000 nodes, 500,000, but 30 gigabits of RAM, dedicated machine, very strong, but it's possible. But the problem here is that what are the questions you can ask visually with so much element on the image? It's totally different. I mean, when the network is very small, you will be more interested in what are the attributes of the network, what are the properties of each element, what are the quality of the connections. If it's more quantitative, you will be more restricted of the connections, and maybe we'll just try to identify some groups or some general properties. It's very difficult. Okay. Okay, good. So, what should I talk you? Little trick. If you want to have the user interface in Russian, it's possible. You go to Tools, Language, and select Ruski. Yes. On Windows, there are some problems with administrator rights. So you may modify the language option manually. If you have it, I will show you how to do. But that will work. Because otherwise, Gephi will restart in the right language. So. Okay, so we have seen the basics, many basics. I mean, we will come back to some specific options after, some details about layouts, about visualization in tomorrow. So now we'll just finish with some more information about the Gephi project. Okay. Well, so because we started this project as students, I mean, we are doing our master in computer science at the university, and with a friend, we are very lucky to attend a course about web networks, web graphs. It was we had a very good professor, not involved in informatics or mathematics. This person had a linguistic diploma, so very interesting. He switched from the document studies, text to the web, and started to be interested in how researchers studied the web as a statistical object, and what we could do with networks. And so we get trapped with a friend. We made a training period in his research lab in sociology, and we arrived. These researchers had a prototype at this time of Gephi, and they wanted to have something useful for sociologists, something that is quite usable, because at this time there was famous other softwares, for instance called Guess from Ethan Adar, but it is mainly about scripting, the modification, layout, etc. And for sociologists who are really don't really like computers most of the time, or they are very concerned about how a novel tool could bias their own methodology, it was no way. So we created a new tool to help, well, this kind of researchers and more people to deal with networks. I mean, today we continued like that. The researchers told us, okay, we do sociology. It's not our job to develop an open source project. So if you want, we give you everything. It's up to you. It's your baby now. So that's totally crazy. I mean, you are a student and you are able to contribute with a real world project and doing open source also. So we get trapped and we continued. We opened a blog and well, at the beginning, most of the people were not able to install Gephi. It just crashed. Well, we discovered that many other softwares, professional softwares, also crashed to analyze. So people were disappointed for network analysis most of the time. So we created a software that most of the time doesn't crash on install and on loading a data set. And after that, we discussed with many people, our early adopters, people interested in finding the tool interesting, but well, not enough usable for us to better improve it progressively. And well, it spread out more and more. And it is totally crazy because we had to try to manage this the interest in Gephi. Now when we make a release, we have 60,000 downloads. Start to be interesting. I have thousands of messages on the forum. I'm contacted by email regularly by people who have questions or want to know if how they could partner. We created to make this project live. We created a non-profit organization in France, which is called the Gephi Consortium, to get more, to be able to contract, to partner with the companies and the research laboratories, also to exist for these people. It was really important. And we were also really lucky to get accepted to the Google Summer of Code. If you don't know it, the Google Summer of Code is a program where each summer Google pay students to contribute to code on open source projects. If you haven't done it so far, try to find some information on the web. There are about 200 organizations of open source projects, Apache, Mozilla, etc., who benefit from the program. And they also accept smaller projects, well, like Gephi at this time. And since 4 years now, each year we take between 5 and 7 students. We try to give them a very interesting project, something for at the edge of the technology, to well, just for the challenge and see what's going on. And for the people who like the experience, well, they stick on the project, they become regular contributors. And so this is how we started to create an open source community. So if you have also there are also other projects for graphs and network analysis during the Google Summer of Code. A very good one. Well, you may certainly already have been in the website. Well, if you want if you want to create a user group to help each other to use Gephi or have questions about it, we can promote it. We can say, okay, if you organize a meetup, let us know. We'll say that, okay, there are these people in this city who are organizing a meetup, and most of the time can be, well, people, even if they don't know Gephi, but, well, don't use it, but know about it, and they follow our blog or Twitter, and they are interested in about networks. If they are close to you, they will contact. They will come to get curious, to discuss. It's a very good way to create a local community. So for the moment, people created one in Berlin, in Germany, one in Paris, of course, and one in San Francisco. And well, for the developers who help us, notably during the Google Summer of Code, we try to find a win-win relationship. I mean, if he's a student and want to find a job after, we can promote his work at Gephi if he has done well. People write blog posts about it, and for some of our contributors, it worked very well because one of them works at Amazon, another one at Google, another one at Facebook, and another one, actually the main developer of Gephi, is working at LinkedIn. So it is also a quality label as a Gephi developer. So I receive also sometimes job opportunities, a company who want to hire a Gephi developer, or in some job descriptions you have in the skills Gephi. That start to be cool. And we want to run the community for the long term. I mean, we try to identify business opportunities, but it's more on the case-by-case basis until now. And if we don't sell the software, we almost don't sell services. We try to put more value on the people who contribute on it. So people who continue to use Gephi during a long time become Gephi experts, and they can easily sell their expertise to other companies. But this starts to create a kind of ecosystem. And we have this non-profit organization where we come, where we discuss about long-term challenges. What should we do? The next step about network visualization. What are still the pain in this area? So we see the thing for the long term. And we try also to integrate with other technology. So for instance, in Gephi, well, I would say just after, well, people use Gephi also for very different meanings. I mean, people use it for presentation on business, or, well, I cheated a bit about leisure, but people like to show that they made a beautiful graph. It really helps. I mean, sometimes in research, there is a kind of thinking that if an image is too beautiful, it's not really science, it's data porn. Really. You can Google it. But it really helps. I mean, you'll create something that is beautiful. It's really motivating. And we found also that where people find beautiful visualization of networks, they get more motivated to dig inside the data, to spend more time on it. So it's not totally, actually, it's not useless. It attracts attention on your job, on your study. So that's quite good. And sometimes also there are some people who do very strange things, like, for instance, here in fashion, a fashion designer in London had in a master degree in a London College of Art wanted to study how people will represent themselves, and so social network was part of our identity, and so he wanted to create this clothes with that show the Facebook network of this person. Okay, that's kind of experiment. So just going back about the integration in the technical ecosystem. So with Gephi, you can get data in various ways. So for instance, from files, very different file formats. It's a mess to deal with networks. Everybody wants to create their own file format. We did also. But you can connect to databases. So relational databases or more and more graph databases like Neo4j. And I will show you also graph streaming features. I mean, Gephi can send or receive network events in real time and display it. For instance, you crawl the web and you want to see the network you have crawled. You can see it. And also you can export data in various ways, etc. Well, I will stop. Yep. I will stop it now. Thank you.